Okay, so we are talking now about the project that you are basically watching me do. So this is your 15-point project that you're doing. This would have been you doing the project like we had talked about in class for the last couple weeks of lab. But instead, I have basically done a project which you're going to watch a bunch of videos. This is a couple hours of content. And then you're basically going to answer basically do an online test about this project. So I am going to give you the questions before. So that's what this video is about. This is all the questions that you will need to watch for when you watch these videos. So this is going to be a start to finish development of a PLC program with safety, and then implementing that program, doing basically the startup of it with the machine and making it run. Okay, all those steps. The simulation's already done for you, so we're not watching how to build the simulation. So this would be very similar to if you were actually working for a company where somebody contracts you, they have already built a machine, they contract you to do the programming for that machine. So here are the questions that you're going to have to answer. So how did I create the logic and tags for this project? I talked quite a bit about that. So where do they come from? What was the most time-consuming and boring process in creating a program of this particular size? So I talk about that in there. What are the steps to the sequence? So we develop a sequencer, know what the actual steps in order of that sequence are. What are the safety devices that are used? How many of each type of safety device are there? Know what those are. And then how are those safety devices used? So if you push an e-stop, how is that different from opening a safety gate? How are those things used differently? In the safety PLC example we did, we had a couple different zones, things like that. How are things used in this particular project? How many different motions are there in the program? So individual motions, how many are there? Is the roller stop that we use here a single or double solenoid motion? You should know what that means. Look for what it is in this program. When we do the startup of the machine, what function do we always want to do first when we do a machine startup, and why? Why is that? I talk about that quite a bit. You'll notice in this program as well, I don't put in the JSRs in the standard logic right away. There is a reason for that I talk about. So why is that? Why don't I put the JSRs in right away? There is some logic in there to make the elevator freeze in place on a safety stop. So if the elevator is moving, if it's raising and you hit an e-stop, it'll actually just stop and freeze in place wherever it is. Describe what that logic is that makes it do that. What are the conditions that define home position for this particular machine? Know what those are. I took some time to figure out how to get the load complete signal to work properly. The way I did it the first time around in the logic didn't work. I was actually wrong in the way I thought it should work. And then when I when I did the machine startup, I actually figured out how it should work. So what was it that I did wrong, and what was the final condition that actually did work for this? So have a look at what I did wrong, or what my thinking was that was wrong on that. What does the math for parts per hour look like? Know what that math looks like and how to explain it. What is a typical cycle time for this machine in the end when it's actually running? And then what was the general order of tasks for starting the machine up? That should be consistent with the way you would start up any type of machine, the way that we did here. How many parts per hour would this machine run if we let it run? We actually calculate the parts per hour, so if it actually just runs for a little while, where's that number going to kind of settle on for parts per hour that you'll see? How many faults are there in the fault logic that are programmed in here? And then what fault do I actually demonstrate during the testing of this machine? What combination of bits from the vision system to find a blue part. So we have to figure that out during the testing. You can see me do that. What two routines were written after the code was downloaded? So the majority of this code was all written offline before it was downloaded, but there's two routines that I didn't do until the program was actually downloaded. What are those? And then what things did I forget to do in this project that I did in other labs? There was two things looking back at this that I actually forgot to do. See if you can figure out what those are. They're things that we demonstrated in functionality we had in some other labs that I did not do in this lab that I should have. So see if you can pick out some things, and then if I give you a multiple choice question from a list, what things did I not do in this lab that I should have done? Okay. So good luck. Watch the videos. Know these questions so you know what you're looking for. And then at the end, you're going to do the test. The test is going to be a multiple choice test. It will be a timed test. You will only get one chance at it. It will not allow backtracking. And yeah, it should be a good test to see how well you understand this logic, but you know the questions ahead of time. All right, so good luck. Hopefully this is not as good as being able to do the project yourself, but it should be a pretty decent sample of whether you understand how you could have done a project by yourself. Okay, so good luck. Thanks.